Wait, last time we took the pain to go through units, what units are. So this time we promised that in this session we'll be talking about prefixes. We had a small taste of it in the previous session. Let's look into what prefixes are, how they are helpful for us, and especially how they relate to units. So let's do this simple exercise. Imagine that I have something I measured in units, right? It can be height or say I say 2 meters, right? In meters, right? Then I say 0.2 meters, and then I go ahead and say 0.00002 meters, or I have 220 million. I don't know how many zeros I'm writing, kind of, or I have 0.0000112 meters. Yeah. So you see that the first one is very simple for us to handle. It's just 2 meters, 2 meters. So when you are going down, you see that the number of zeros are increasing, right? Or the number of decimal places are increasing, or the number either becomes smaller or the number becomes very big. So 0.2 is smaller than 2, right? So you get big, lower. But then this one is also lower. So the number gets smaller and smaller and smaller. And then this one, the number just got huge. 2 just got huge. It's no more like the same in magnitude. Now it's like, let me see how many zeros I have. I think that's 20 million meters, right? Then this one, so there are 0. The number gets smaller, smaller in this case. Okay, so but then something like the 2 meters is simple to handle. Is that not it? So what happened is that the units that we are having here is in meters, and we saw the importance of units. It helps us to know that this is something to do with distance or separation, right? Yeah, so that's what unit does. But then unit needs some assistance. This unit needs an assistant. And the assistant they need are prefixes. Prefixes, what they do is that they help to change the numbers, like the magnitude, right, the value, right, to something, a numerical value that they can actually handle, so that can easily be read. Okay, so if you want to write this thing in how do you call it, scientific notation, right, we'll say 2.0 times 10 to the power negative 1 meters. This is the same as this, right? Then this one, that will be 2.0 times 10 to the power, how many 0, 1 2 3 4 5, so negative 5 meters. And then if you change this one, is 2.0 times 10 to the power 1 2 3 4 5 6 7, so that's 7 meters. Then we have 0.000007, and then we come here. So in scientific notation, 1.12345 1.12 times 10 to the power negative 6 meters. Yeah, so this, so just transform it to a scientific notation, right? Scientific notation is just one of the simple things that you need to have as a mathematician or as a physician, right? Yeah, so this is this number is the same as this, right? This one is the same as this one is the same as this, right? But then you are seeing that the decimal point, the decimal power is changing, right? They are different. They are getting bigger or smaller. Then scientists also thought that, okay, if you, instead of having, before you, because you want to have something like 2 times that, you don't want to be handling those 0 point something plenty, or 2,000 or 2 million. We don't want those plenty zeros. We just want something simple to handle as a value. Then the unit will be adjusted in a way that it captures the decimal component, right? So that the value doesn't, the original value does not change, right? We need to change the decimal component that we have. That's when prefixes come in. They what they do is that they come and then they replace this decimal component, right? This decimal component, they allow to change very small numbers to something like to make it easy to handle, right? So something like whole like this. Or yeah, so in this case 2.0 times 10 to the power. So this is the decimal component that changes to this. This is a decimal component for this one, and this is the decimal component for this one. But anytime we want to use this, right, we want to make sure that we just handle the decimal values, the magnitude, actually the value that we have changed, right? And we want to maintain this decimal component. This decimal component needs to be changed with a particular unit or a particular symbol. We can change this into a particular symbol. So scientists have find a way to change this decimal component into particular symbol. So this one can also be written as 2 decimeter. For 10 to the power negative 1, the the symbol that they use to replace that is deci, yeah, deci or deci, and the symbol is D, right? That's what they use to replace the 10 to the power negative 1, so that the number can easily be read like 2 decimeter. So 0.2 meters is the same as 2 decimeter, right? So deci is just 10 to the power negative 1. That's this. That you are changing the decimal component into something symbolic, and so that you can attach to the original unit. The unit doesn't change, right? Deci is just a prefix that's attached to that. So all these symbols that we attach to this are called prefixes. The symbol that I use to represent the decimal component, or they are used to replace the decimal component, are called prefixes. If you have a decimal component that is 10 to the power negative 6, then what you are going to use to replace it is the micro, and then this is the symbol for micro. So at the end of the day, I can write it 1.12 micrometers. You see that? So the 10 to the power negative 6, I just replace it with this, and the meters is always there. So the unit is there, and then prefixes also allow that. If you watch in the previous video, you see that the standard unit for mass is what? Kilogram. So the unit actually, the the name of the unit actually is gram, but then what is K is doing there? K is just is a prefix that's attached to that. So then we call it kilograms. So it means that grams is the name of the unit, actual name of the unit, and kilo is just a prefix. So we'll look at that prefix on the next video. Now, that's the fair idea about prefixes, right? Now let's go to the formalities and actually define what prefixes are. Yes, so these are prefixes, right? Prefixes are symbols. They are symbols in the. So before I read the definition, let me just put an example here. We put two, for example, we say micrometers, right? Micrometers. So let's focus on this. What are prefixes? Prefixes are just these symbols. That's what basically we are defining, right? So what are prefixes? Prefixes are symbols. They are symbol. They are symbol like this one in the unit of physical quantity. So this is the unit. And when they come together, they form the unit. But then the unit has the main part itself, the original name itself, and has the symbol, mostly this symbol attached to it. So they are symbols in the unit of the physical quantities used to represent. So these ones are representing decimal multiples of large numbers. So if the number is just, we are keeping the decimal multiple of it, or if the number is very small, we use the decimal sub multiple. We use the decimal sub multiple, because they are the one that power negative 1, 10 power negative 2, 10 power negative 3, and so forth. So they are the sub multiples decimal component. And then those that are large, like 10 to the power 6, 10 to the power 7, 10 to the power 8, those large ones that are positive, they are decimal multiples of that. Just the difference. So prefixes are symbols in the units of physical quantity used to represent decimal multiples of large numbers or decimal submultiples of very small numbers. 0.00002 is a very small number. So you can change that to 2 times 10 to the power negative 6 meters. Then we have 2 micrometers represented. So the micro, which is the mu here, it just represents that decimal component. And the name of that symbol that we are using is called a prefix. So now let's look at all the prefixes together, the common ones. The common one, you're not doing all actually. I'm looking at the common ones. So let's look at the submultiples first. So for the submultiples, these are the prefixes, their names, their values, and then the value that they can replace, and also the decimal component. So then for this case, let me use a black pen. So for this case, the first one is deci. So we are looking at the submultiple, meaning those are the power negative stuff, right? Deci is 10 to the power negative 1. We saw it already. So when we have 10 to the power negative 1, we have to replace it with deci, and the symbol that we use is D, but the name is deci. So decimeter. So the name of the unit is meter. Because you replace it with the D, it's not going to be the 2 decimeter. Remember, right? Good. Now you have the centi. Centi is for this one, 10 to the power negative 2. The symbol is C. So if you have like something like 2 centimeters, 2 cm, yeah, 2 centimeters, something like that. Yeah. Now milli is also 10 to the power negative 3. You have m for that, so you can have like 2 millimeters. So meters is the name of this, but this first m is the milli. So prefix come before the name of the unit. Prefix always follow. Um, Prefix always follow the magnitude. So prefix come before the name of the unit itself. So this m shouldn't confuse you. This m is the meters, but this first m is milli. Milli is the prefix. 10 to the power negative 6 is micro. This is the unit. So you did it already, 2 micrometers. Then nano is 10 to the power negative 9. So you have 2 nanometers. And then pico is 2 picometers. And then femto 2 meters. This one, let it not confuse you, right? This is femto. Great. So, but then mostly, if the stress you is just focus and wait here at pico, but then it's rare case, but then you need to have that, right? Your calculator too is there, so we'll look at that, solving most questions in future in this series. Yeah, so that's how to handle that one. Now what about the next one? Now these are the decimal multiples. Now we have left the negative ones. I think for the decimal multiple, is the opposite of the first one, right? So it's not supposed to be negative in this case. It should be what? Positive. So because for the first one, I'm just going to maintain it as 10 to the power 1. But anything to the power 1 is just 10, right? But we keep that. So here we just remove the negatives. That's what I want you to understand. We are just removing the negatives of the first one. Then we are getting this. We are getting this. Yeah. So now if you just remove the negative of the first one, you are just going to have this attached to your values. Now what do I have now? You see, yeah, now we are going upper, right? Decimal multiples, not sub multiples. Is 1, 2, 3. Then from 3, after you get to 3, which is kilo, which is more symbol is k. Now you see from here to here, now we are having the difference is now the power difference is now 3, 3, 3. So 10 to the power 3 to the next one is 10 to the power 6, 10 to the power 9, 10 to the power 12, 10 to the power 50. So we are adding 3, 3, 3, 3, 3. So this is kilo, deca, hecto, kilo, mega, giga, tera, peta, right? Petameter, whatever, kilometer, kilogram, megagrams. So these are the prefixes, right? They are just used to represent what? The decimal multiples of large numbers, in this case, for the decimal multiples, or in the decimal sub multiples to represent the decimal sub multiples of very small numbers. So if it's very small number or the power of the 10 is negative, you use the one of these, and then you have to also see the trend. The first one is 1, then you get to 2, you get to 3. The difference is 1, 1. But if you go from 3, once you get to 3, the next one is the difference is 3. The difference is negative 3, like that, right? Negative 3. You can see that, right? So negative 6, negative 9, negative 12. Once you get to 3, the same thing for sub multiples. Yes. So yeah, for this one, for the multiples, right? At least you know up to giga. At least you have to know up to giga. 10 to the power 9. If you go down, like add the tera or this thing. Yes, mostly we will solve questions, and these are their symbols. So mostly in the units, right? You'll be seeing these symbols attached to the unit, inside the unit. So we said what these are what prefixes are. They are symbols, right? Remember, they are just symbols. They are symbols attached, that they are symbols in the unit of physical quantities. They are used to represent decimal multiples of large numbers or decimal sub multiples of very small numbers. Yes, so prefixes help you to not just to make numbers that are large more readable, or numbers that are very small more readable, but what they also do is that they help to convert from one unit to another. You can convert from deci to milli. You can convert from kilo to hecto. You can convert from mega to peta. Unit conversion is what we are going to be doing next. So kindly be in touch so that we continue building this concept. See you in next video.